this one here is a bit tricky, but if I go back in time, it's interesting because it doesn't look outrageously different. Whoops. To 431. 431 worked out to be a little bit different because of the 2t here. So it meant that the substitution kind of simplified it to this. Whereas that's not going on here, because the cos makes it instead of the sine. So I'm wondering if I can do a little sneaky trick here. Little sneaky trick. So like, okay. Let me check something here. Oh, whoops. 1 second. Think we can do a switcheroo. We think about it like this, perhaps. Let's try and make some space here. So here's the graph for cos, and here's the graph for sine. So if we want to calculate the cos of something, let's say like the cos of x here, that would be like calculating it on the sine graph just out here. This is it coming down from its peak, plus a pi over 2. So what I could do is I could change this integral into this one here into 0.5 cos sine tan inverse t plus pi over 2 all over 1 plus t squared dt. Then if I use a rule here, a substitution, I could say let u equal, that's not quite gonna work, is it? No, that was a sneaky trick that I don't think works now. I need another sneaky trick. Let me think of something else. Okay. Okay, so I had to watch a quick YouTube video on how to do this, because the substitution I wouldn't have guessed. It's quite hard, quite a bit more difficult than the other three. So yeah, we start off with the usual triangle situation here, t1 and root 1 plus t squared. So then the integration becomes 0 to half, and then that's 1 cos is 1 over root 1 plus t squared with the original 1 plus t squared dt. So that is 0.5 1 over 1 plus t squared power 3 over 2 dt. And this is where I had to watch a video. I'll put the link into the description or the comments or whatever, because I wouldn't have guessed what substitution to use here. But the substitution, funny enough, is to use the substitution u equals tan inverse t. Because that means du dt would be 1 over 1 plus t squared. So that means du is equal to that dt. So then the integration would become 0 to the half, and these are t's, by the way. 1 plus t squared over 1 plus t squared power 3 over 2 dt. That would equal 0 to a half, and that would be 1 over root 1 plus t squared dt. And that would be sine inverse t. So that would be sine inverse t, which is tan u. Right? No, what have I? U equals tan inverse t. So du dt. So that's that. No, I'm sorry. I confused myself. I'm trying to get it into the terms of u. Okay, sorry. So the integration dt is 1 plus t squared du over 1 plus t squared power 3 over 2. So that is the integration of 1 over root 1 plus t squared du. And the t, we can try and figure this out from the triangle. So that is cos, but maybe I should just put in 1 over root 1 plus t squared, which is 1 plus t squared, just tan squared u du. Okay, now just remember what 1 plus tan squared is. So I think it's like sec squared, is it? 1 plus tan squared, that's sine squared over cos squared. That's cos squared plus sine squared over 1 over cos squared. So that's 1 over cos squared, which is sec squared. So that's the integration of sec squared u du. Ooh, okay. No, it's not. Sorry. Well, I'm all over the place with this question. 1 over root sec squared u du. So that's the integration of sec u, which is the integration of tan u du. Okay, and that's the integration of sine u over cos u du, and that's minus and minus, so that's minus log u, which is, with the limits, minus log tan inverse t 0.5. So that would be log tan inverse t 0.5. Oh dear, that's wrong. That's gone wrong. That's gone wrong. That's gone wrong. Oh, sorry. I'm wrong at the end. I'm just really not having a good time with this question today, am I? 1 over sec is not the same thing as tan. I'll get this. I'll get this. I'm also getting hungry. Sec. That's 1 over sec is cos u du. So that is sine u, and sine u tan inverse t. Which is 1 over root 1 plus t squared. I feel like something's... no, sine is... yeah, sine is t over that. Okay, so that's 0 to a half. So that would just be a half over root 5/4. Let's see. So that is root 5 over 5. That's the answer. So let's check. Let me just check that. See if that is right. Yep, that's right. That's a tough question. That's a tough question. No hint about the substitution to use here.